Hey, this is Coach Olson Math, and we are looking today at multiplying and factoring polynomials. We're looking at the basics of that, and there's a few things we need to know before we start this. The first thing is what a coefficient is. So a coefficient is the number part of a term, okay, of a variable term. So it's a number multiplied with one or more variables. So if we have a term that looks like this, x squared y, the coefficient is only the number part. It has nothing to do with the variables. It's just the number part. Okay, so it doesn't matter how long the term is, the coefficient is the number part of that term. And when we multiply numbers with terms like this, you multiply like things together. So if we're multiplying that by 3x, the coefficients get multiplied together, and then the exponents will get added because you're multiplying the same like bases here. So you would add exponents. Okay, those are coefficients, the number part of a variable term, or a number that is multiplied with one or more variables. GCF, we should remember that from way back our elementary days. It's the largest number that can divide two or more numbers evenly. So if we're looking at, say, 4 and 16, both numbers are divisible by 2, but that's not the largest number that divides them evenly. The largest number that divides both evenly would be 4. So we would say the GCF, or greatest common factor, is 4. This is a common factor, but this is the greatest common factor. So we're looking at the largest number that's going to go divide into what we're looking at evenly for GCF. Okay, one more thing, I don't have it down, but what factors are factoring. Factoring, it's like, it seems like we're going backwards when we do that. So let's say I multiply 3 times 5. Well, I get 15. 3 and 5 are factors of 15. So when we're factoring, we're going from this back to something like that, in a sense. Okay, that may seem counterproductive, going backwards, but there are times you need to factor to solve equations. So we're going to look at the basics of factoring today, which will help us out later in solving equations. And we're going to look at multiplying polynomials together. Example 1 has us multiplying polynomials of degree 1. Degree 1. So in other words, this monomial out here, negative x, has a degree of 1 because its exponent is 1. This binomial inside the parentheses has a degree of 1 because this term has a degree of 1 because its exponent is 1. This term has a degree of 0 because it's a constant, doesn't have a variable. So we're multiplying a degree 1 monomial to a degree 1 binomial. Okay, and that's what example 1 has us doing. So let's go through these pretty quickly. They're not very hard. Okay, now remember, like things get multiplied to like things. So the negative, that's really a negative 1 times 9, and that's a negative 9. And then it's x times x. Well, it's x1 times x1. You add the exponents when you multiply bases. You get negative 9x2. Now, that is a negative x times 7. So it's a negative 1 times 7, which is negative 7. And then it's just the x goes with it. So it's negative 7, negative 9x squared minus 7x is our final answer. Okay, these are not like terms, so you cannot put them together. You have to leave them separate. Keep going. 5n times 3n, well, the 5 and the 3 are coefficients. They get multiplied. That's 15. N times n is n1 times n1. You add those exponents, becomes n2. Okay, and then 5n times 8 is 8 times 5, which is 40n. 40n. And again, these are not like terms. I do not want to add them together. Moving on, we've got a negative 3x and a negative 6x. Well, the two negatives cancel each other out, make a positive. 3 times 6 is 18. x1 times x1 is x2. Keep going. That negative and that negative are going to cancel each other out, make a positive. Okay, so I've got 3x times 9. 9 times 3 is 27x. 27x. Negative y times y is negative y squared. It's a y1 times y1, that's y2. Negative y times negative 3 is positive 3y. Positive 3y. Mainly with these, you have to watch the sign and watch the exponents. Other than that, they're pretty simple. Negative 2z times z is negative 2z squared. Negative 2z times negative 4 is positive 8z. Positive 8z. Okay, last one of these. 3x times negative 4x is negative 12x squared. And then 3x times negative 2 is negative 6x. Negative 6x. So this is multiplying polynomials. When we factor, we're actually going from something like this back to something like this, which that's what we'll be doing a little later in the lesson. So that's factoring. Multiplying, it seems like we're going forward, we're doing something, we're getting rid of parentheses. Factoring seems like we may be going backwards, but that's what we have to do sometimes to solve equations. Okay? And that takes care of example 1. Okay, with example 2, we're going to do something that's going to help us with factoring. Okay, we're going to look at the GCF of polynomials. The GCF of polynomials. Okay, and what we have to do when we're doing this, we've got to look at the numbers separately from the variables. Okay, but our GCF is going to be one term. It will be one term. It will be all together, but we're going to look at these separately. So I'll look at 5, 25, and 45. Well, obviously the largest number that divides into all of those is 5. So the GCF of the numbers is 5. Now look at the variables. What variable divides each of these evenly? Or you can think of it like this. What do they all have in common? How many x's do they have in common? Well, this one only has 1, this one has 2, this one has 3, x3, x2, and x1. They all have at least 1x. Okay? They do not have at least 2 x's, they all have at least 1x. And so that is the GCF of the variables, what they all share in common. So it's 5x. Okay? X divides x evenly, x divides x2 evenly, and x divides x3 evenly. So 5x is the GCF. And that's it. Okay? Keep going. Next one. I've got 3, 9, and 12. Well, obviously 3 goes into all of those. And look, I've got x4, x2, and x1. Okay? X to the fourth, x to the second, x to the first. Well, what do they all have in common? Each term has at least 1x. They all have 1x in common, so it's 3x for my GCF. X divides each of those evenly. 3x is the GCF. Okay, keep going. 4, 6, and 12. 4, 6, and 12. Well, obviously it's 2. 4 doesn't go into 6 and 12, but 2 goes into all of them. So the number part is 2. Now look at the variables. I've got x2, x3, and x5. How many x's do they have in common? How many x's do they all share? That's x2. They all have at least 2 x's. So x2 is the variable part of that. So my term, my GCF, is 2x squared altogether. Okay, moving on. I've got just x's. That makes it really easy. Well, each of these, that's 3 terms. This is a trinomial of degree 3. How many x's do they have in common each term? Well, each term only has 1 x in common. So the GCF is x. X goes in x3, x goes in x2, and x goes in x1 evenly. Okay? Keep going. I've got 16x6, 20x4, and 4x2. Well, 4 goes into all of the numbers, so 4 is the number part of that. And they all have at least 2 x's. So x squared is the variable part of the GCF. I'm going to put that together, and my answer is 4x squared for the GCF. Here, I'm doing each thing separate. So I'll look at all the x's, and they all have at least 1 x. So x is the x part of my answer. That's a very bad x. It got worse as I went along. Okay, this one has y2, y3, and y1. So they all have at least 1 x and 1 y. So the GCF of this trinomial is xy. Okay, and this will kind of set us up for factoring. So in the last set of examples, we found the GCF of the polynomial. Now we're going to find the GCF and actually factor these binomials and trinomials using the GCF. Okay, remember, factoring was like going backwards. We took when I showed you the example earlier, we said 15 is really 3 times 5, right? You multiply these, you get 15, but if we go backwards, we divide it up into its factors. There are other factors of 15, like 1 and 15, but we divide it up into its factors. And this would be called prime factorization because 3 times 5, both of these are prime. So we're going to basically take this binomial and divide it into 2. We're going to pull a monomial out of that. So the GCF of this binomial, 4 goes into both of the numbers, and they each have at least 1 x. So I pull the GCF out of that, okay, Now, in the parentheses, I put what's left in there. So if I divide 4x squared by 4x, I just have an x left, because 4x times x is x squared. If I divide 24x by 4x, I just have a 6 left, because 4x times 6 is 24x. And this is the factored version of this. Okay? Again, we pulled out the GCF, and what was left over is inside the parentheses. So we're just working backwards here. Okay, here we got a 9x3 and a 15x2. I think 3 is the largest number, and they both have at least 2 x's, so x2 is the variable part. Parentheses. Okay, 3x2 times what is 9x3? Well, it's going to be 3x. 3 times 3 is 9. x1 times x2 is x3. 3x2 times what is 15x2? Well, that would just be 5. 5 times 3x2 is 15x2, and now this is factored. Okay, coming along to the third one, we've got a 6 and an 18. And generally, if it leads off with a negative, you want to factor out a negative, okay? We'd like to have the first term in here positive. So if this first term is negative, let's factor out a negative. So I know that 6 goes into each of those, and we're going to pull a negative out with it, so negative 6, and they both have at least one x. Okay, now we put parentheses here. Negative 6x times what is negative 6x squared? Well, times x. Okay? Now, negative 6 times what is negative 18x? Well, that is positive 3. 3 times negative 6x is negative 18x. So we factored out the negative 6x, and we were left with positives inside the parentheses. Okay? Keep going. This trinomial, well, I've got 4, 2, and 8, so 2 is the GCF of the numbers. And they all have at least one x, so that is the GCF of the variables. 2x times 2x3 gives me 4x4. 2x times x gives me 2x squared. And 2x times 4 gives me 8x. Okay, all positives. There's nothing negative here, and that is factored. 5x squared minus 15x plus 20, you factor out a 5. This one does not have an x, so they do not all have an x. They do not share an x, do not have an x in common. So I'm just factoring a 5 out, not the x. 5 times what is x squared? Well, 5 times x squared is 5x squared. I'm sorry, I may have said that wrong. 5 times x squared is 5x squared. Yes. Okay, 5 times what is negative 15x? Well, that would be negative 3x. 5 times negative 3x is negative 15x. 5 times what is 20? That would be a positive 4. Okay? And you can always check your work. 5 times that should give me that. 5 times that should give me that. 5 times that should give me that. Okay? It's easy to check. Again, I'm leading off with a negative here, so I'm going to factor out a negative. But there's the GCF is 1, because that's really a 1, and that's really a 2, and 1 is the only thing that goes into both of those numbers. So I'm really factoring out a 1. I don't really have to write the 1 unless there's no variable part to it. But they both share at least 2 x's. They both have at least 2 x's in common. So I'm factoring out a negative 1x squared. Okay, now in parentheses, I've got to multiply this by a 2 and an x2 to give me this. Okay, that gives me negative 2x4. And I've got to multiply this by what? Well, this and this are the exact same thing. Negative x squared, negative 1x squared, the exact same thing. So I'm just multiplying by a positive 1. Multiplying by 1 gives me the same thing that I start with. Okay? And that is basic factoring. That's as far as we're going to go with factoring today. Example 4, we find a problem involving a shape, or shapes, actually an area problem. And we're using some basic area formulas, one for a circle, one for a square, or rectangle. So if you notice, we're going to find the area of the shaded region, and to do that, you find the area of the whole thing, the whole shape, and then you're going to subtract the area of the circle, because that's been cut out. So let's find the area of the rectangle first. That is base times height. Well, it's 2x times 2x. And if we multiply 2x times 2x, we get 4x squared. So that's the area of the rectangle. The area of the circle is pi r squared. Well, the radius is x. So it's pi times x squared. Instead of r, we're going to leave pi. We're not going to make it 3.14. We're just going to leave it pi in terms of pi. Now to find this shaded area, you simply subtract these. So I get 4x squared minus pi x squared. And the last thing we're going to do, you can't really do anything else to this, we're just going to factor it. Okay, they both have, the GCF would be x squared. They both have at least two x's. You pull out x squared. And inside the parentheses, I'm left with a 4 minus pi. Okay, x squared times 4 gives me 4x squared. X squared times negative pi gives me negative pi x squared. And that is factored. Now, if we wanted to substitute 3.14, we could certainly make this a little simpler, but we're going to leave that as pi. Okay, leave that as pi. And that is the factored form of our answer. That takes care of multiplying and factoring, or the basics of multiplying and factoring.